Welcome to the equilateral and similarities coming to triangles. So we have a problem here. As you can see that we are required to prove that triangle CDE is similar to triangle that we're going to be a CBA here. So now we draw this triangle, and that is there that we drawing the CDE, and then from the CDE there, that is that, and then we take also that is the sub triangle, and then we take in the main triangle, which is ABC, in this case CBA. Then we can see the similarities between those two triangles. So what you're gonna do, we're going to say that this part is R1, which R1 is the hypotenuse opposite the right triangle, X2 the base, and then Y1 the height. It's actually R1, Y1 and X2. Then we have R2, Y2 and X2. So they are similar, irrespective of how they look like with how they face. Now we can see that that is 1 and 2. So we have two triangles there. They can take them as step 1 and 2. And then coming to step 3, we want to prove that the two triangles are similar. So angle C, as you can see, that is common. Both triangles, they share it, so which means the angles are the same. Alright, and then we have the right angle there, which is E1. So we have E1 there is equals to angle A. So that is angle A there. Reason is 90 degrees. Okay, and then we have two angles now. So in triangle, like the sum of 3 triangles make 180 degrees, the interior angles. So if two angles are similar or equal, then the third one are also equal. So that's how the triangles work. So you only need to prove that 2 are equal, then the third one is be automatically equal. So we have this reason as sum of triangle, so you can just leave it like that, you know. And then hence, after we have proved that, it shows that the triangle CDE is similar to triangle CBA, and proved. So that is it, you know. And then we have to go to the other question. So that is it. So the other question says determine the length of EC. So we go there, as I've rescaled the EC there is going to be Y1, and then we have okay, so that is question B, where we are required to find the length EC. So coming to the length EC, okay, we know that that is BC there given as 40, that is R2, and then we have DC there given as 18, you know. And then let's just write the information. BC is equals to 40 meter, that is equals R2, and then we have DC there as 18 meter, that will give us R1. So R1, that's the distance there, and then we have AD is equals to 12 meter, and then that is equals to 12 AD. And then we have to solve the part that AC is equals to AD plus DC, and and that all gives us y2, and that is because 80 is 18 plus AC is 18 plus 12. Okay, so those are the two sides, and then we have EC is equals to what. So EC there, as you can see, you can give it to y1. So now we use ratio. Okay, so ratio things out, and then what we have there, we have R2 over y2, so that is R2 there over y2. Okay, so we have y2 there is equals to 30, because that is y2 there is equals to 30. And then we have R1 is equals to y1, R1 y1. Now you can see that that will give us R2 is 40. Okay, these are just the steps that we need to number up, so that if you have any questions you can refer to the steps. And that is step 2 there, which is we calculate AC to give us y2, and then step 2 that we use the ratio. So that would be R1 is 40 over 30. Okay, 40 over 30 is equals to 18 over y1. Remember, y1 is the EC that we need to calculate for. Then we cross multiply, that will be y1 times 40 is equals to, that is 18 times 30. Then in this case we divide by 40 both sides, and then using our calculator you find that it's 13.5 meter. So that's our final answer, so yeah, so that's step 4, giving us the answer EC is equals to 13.5 meter. So similar triangles, we use ratio in order to find the answer. So that's it.